Yeah.
Hello, how you doing? It's Mr. Do the Math, and today we're going to talk about transformations of linear and absolute value functions, right? So we've already kind of talked about it, but we're going to dive deeper into all of our transformations, right? We've talked about the so we're going to focus on four transformations. We're going to talk about translations. Talk about translations, reflections. I don't know if I spelled reflections right. And dilations. Right? That's what we're talking about. So we're going to talk about flipping across the x and y axis. We're going to talk about stretching and Stretching and shrinking. Stretching and shrinking, and we're going to talk about vertical and horizontal shifts, right? So reviewing these vertical shifts, we're going to talk about vertical shifts first. Vertical shifts. What's going on? Oh, vertical shifts. All right, so vertical shifts, right? We're going to focus on our parent function. So associated with the parent function, you have a vertical shift when your x term or your function term has a number on the outside of it. So for instance, if you have, like, say, y equals f of x being the functional term, plus any number c, that means you're going to have a vertical shift. All right, f of x represents our parent function, that being x squared, the absolute value of x, so on and so forth, right? So this will be our parent. This is inside of the box. These are our parent functions. This is the f of x, right? So everything with functions derives from the parent function. So this is descriptive of a parent function. If you add a number to the parent function, that means that you're going to have a vertical shift, right? It's going to vertically shift up, right? It's going to shift up, right? If, for instance, you had f of x, so the parent function minus any number c, that's going to be a shift down, right? So basically what I'm saying is the numbers tell you what happens with your graph, right? Everything starts at the parent function, okay? Yo.
So basically, if it's a negative number, it goes down. If it's a positive number, it goes up.
Yeah, good. So like, let's look at this example here. So if we have, for instance, we have f of x equals the absolute value of x plus 2, right? This 2 is on the outside of, is not connected to the function term, right? The function term being absolute value of x, right? So this is on the outside. So whenever it's on the outside, this is your vertical move. So because it's positive, it's going to go up 2 units, right? It's going to move up 2 units. So write this down underneath that box, right? And so when I graph this, if I graph this, focus around the parent function that looks like this, right? The absolute value of x looks like this. X plus 2, the new function, if I'll dash this, right? The new function then goes up 2 units. 1, 2, and does the exact same thing. So this is what the new function looks like, right? And this 2 told it that it did that. All right, you feel me? Okay. Let's look at another example. So if we had, for instance, g of x equals x squared minus 2. Again, the x squared is the function term. It's the functional term. It's its identity, right? This plus 2 is on the outside, right? Minus 2 is on the outside. And so since it says minus 2, it's a shift down 2 units. So it goes down 2 units. So the parent function looking like this, right? This is going through the origin, right? And minus 2, you're going down, 2. So it'll do the same thing going here, right? So this is where g of x is. Everybody good so far? All right. So these are vertical shifts. Vertical shifts have the number outside of the functional term, right? Horizontal shifts are going to take place inside. So look at the second box, right? So horizontal shift basically is going to be where it's f of x plus c, right? Which means that is going to be inside of whatever grouping symbols that identify whatever our function is. So it's going to be f plus c, right? Or f of x minus c. Now, the difference with being inside versus outside is everything's opposite. So when it's x plus c, you're actually moving this way. So you're moving horizontally to the left, right? So you're going horizontally to the left here. So circle that or highlight that in that box. And then if it's minus c, you're going horizontally to the right. So if I use this example, let's look at this example here, where we have f of x, you're going to write this underneath the box, equals the absolute value x plus 2. The absolute value x plus 2 is inside and is connected with our functional identity, right? This is the absolute value function, right? That means that you're going to move to the left 2 units, right? So whereas the parent function looks like this, the new function is going to look like this, right? So this is the original function here. This is the new function, okay? And we can tell that by this number, okay? Let's look at this one. We have f of x equals x minus 2 pointed squared, right? So again, this is a quadratic. It's raised to the second power, but you're going to move to the right 2 units. That's what this means, right? So you start here. This is our parent function. We'll make it little. And then our new function is going to go 1, 2 over and look like this, right? So this is our new function. It moved to the right. This one moved to the left, okay? Now remember, inside of the grouping symbols, everything's opposite, right? If it's negative, it's moving in a positive direction. If it's positive, it's moving in a negative direction. We good? Give me a head nod, let me know we're good. All right? All right, so cool. Let's look at some. Let's do an example. So look at example 1. All right? Look at example 1. I'll erase these graphs. Example 1. Example 1. It says, given this function, f of x equals 3x minus 5, right? Write the equation if it translates down 2 units, right? It translates down 2 units, right? Translating down 2 units. Translating down 2 units. So translating down 2 units, what's going to happen is down 2, that means you're going to subtract 2, right? So it's going to be 3x minus 5 minus 2, right? This is the down 2 units part, okay? So always add, so basically what you're going to do is you're going to add the transformation, all right? Transformation to the expression or the equation, and then you're going to simplify. All right, so then you got same sign, you're going to add and keep the sign. So it'll be 3x minus 7, right? So f of x, or technically, the new function is g of x. So g of x is 3x minus 7, okay? All right, now let's look at B. B says it translates 4 units to the right. So it's the same original equation where it says 3x minus 5, right? And this time it's going to move to the right, right? And since it's moving to the right, this one is going to be connected to the x term. So you got the 3 here, and then you got the minus 5, all right? To the right means, so as a horizontal move to the right, it's going to be minus the c. So again, it's going to be inside parentheses. So 4 units to the right, it's going to look like this, minus 4. So it'll be x minus 4, all right? So for horizontal moves, put it in parentheses. All right, Della? Now, we put things where they are, and then we're going to simplify it, right? Simplify. So we're going to distribute this 3 through. So let me write that down so we can see the step, right? Distribute the 3 through, bop, bop. So it's gonna be 3x minus 12 minus 5. Then you're gonna combine like terms. So you end up with 3x minus 17, right? So g of x equals 3x minus 17, okay? Everybody see that? All right, so take a look at number 2. Take a look at number 2 and start working on that. That says it's translating 3 units up, and then B says it's translating 2 units to the left, right? I'm gonna make space here and we'll work it out. Have you already worked it out, Ezekiel? All right, let's look at it. All right, so we got this function here, and it shifted 3 units up. All right, shifting 3 units up means that we're going to add 3 to it. So g of x is going to be the absolute value of x plus 2 minus 5 plus 3. How many students had that? Right? And then you simplify that, so you end up with the absolute value of x plus 2 minus 2, right? That's g of x. Okay? Letter B, to the left, that means that's going to be inside of the absolute value. So again, starting here at f of x equals the absolute value of x plus 2 minus 5, right? Then we're going to add our transformation, right? So it'll be x plus 2, and it said it's shifted to the left. Since it's shifted to the left, it's going to be plus 2 in parentheses in the absolute value bars minus 5, right? So the first thing you want to do is you want to add the transformation and transformation notation, right? Station, right? And then 2, you're going to simplify. Right? So we added it here, and we're going to simplify it. So we end up with x plus 4 minus 5. How many students have that for B? Fantastic. Okay? All right, let's go on. Let's look at the stretches. We want to look at stretches now. The next, is that 3, 2? What's number 3 would be? Number 3 would be, all right, let's look at let's look at this. Oh, good. It's not that. It's gonna be reflections. Let's look at our reflections. Let's look at our reflections. I lost my reflections page. All right, let's look at our reflections. All right, so now we talked about translations. Now we're gonna talk about reflections, right? So when it reflects about the x-axis, what happens is the whole function. All right, so again, the x-axis is the horizontal line, right? Y'all remember that, right? So when it reflects along the x-axis, everything is gonna go upside down. So what happens is the function y equals negative f of x, right? So basically what happens is you multiply the whole function by negative 1, all right? So you multiply by negative 1, okay? So, for instance, if I had f of x equals the absolute value of x, right? Reflecting about the x-axis, I would just multiply this whole thing by negative 1. So it'd be negative 1 times the absolute value of x, right? So that's the adding of the transformation notation, and then I just simplify it. So then that's it. That's reflection about the x-axis, right? And so a reflection about the y-axis though is when, so about the y-axis, that is this part here. What happens is you multiply the functional term by negative 1. Multiply. Right, inside by negative 1. Right? So that's what it looks like. It'll be y equals f of negative x. So whatever's inside, you multiply by negative 1. All right. So let's look at that example. So if we had f of x equals, say, let's say x plus 2 squared, right? We multiply that whole thing we multiply the inside, right, by negative 1, right? So that's what it'll look like, right? And so we won't focus much on the y-axis, but we'll go deeper into the x-axis because that's what we're going to see the most of. Okay, so let's look at number 3. Number 3, you got f of x equals the absolute value of x minus 4 plus 6, right? Reflecting about the x-axis, what's going to happen is we're going to multiply this whole thing by negative 1. So it'll be negative 1 times this whole function, f of x, the whole function. So it'll be absolute value x minus 4 plus 6. Okay? Multiplying this whole thing by negative 1, that means it's going to be negative 1 times the absolute value term and negative 1 times 6. So when you simplify it, it'll be negative absolute value x minus 4 minus 6, right? That is g of x. Okay? All right? All right, let's do the same thing for number 4a. All right, we'll skip B. We'll skip the B's here. Let's look at like number 4a. All right, number 4a, you got f of x equals the absolute value of x plus 2 plus 4, right? Reflecting about the x-axis again. Reflecting about the x-axis. So again, multiply the whole thing by negative 1. Somebody tell me what you get as the answer. What do you get? What'd you get?
G of x equals negative absolute value x plus 2 minus 4.
Good. How you sure you got that? Good. Okay. All right. Last part. So we talked about translations, going from left to right, up and down. Then we talked about reflections, right? Reflecting about the x-axis or the y-axis. Now we're going to talk about stretching and shrinking. Stretching and shrinking. All right, so let's create space. Let's create some more space. Stretching and shrinking. All right, so y-axis is f of 1. Right, this is 1 of f of 1. All right, so stretching and shrinking. Right, so basically stretching and shrinking is a lot like the reflection in the sense that you multiply the number by the unit that it stretches by the factor that it stretches by. So if it stretches by, for instance, 5, you multiply the whole function by 5, right? If it stretches by 3, you multiply the whole thing by 3, or negative 3 by negative 3. Okay. So basically, what happens is, the stretch or the shrink is A. right? And so in relation to f of x, it would be a times f of x. So whatever this stretch or shrink factor is, times f of x. Okay? So if we have this example here, let's come up with an example first. If I had f of x equals the absolute value of x plus 4, right? And I said that it shrunk by a factor of, if I said a equals 1/2, right? It'll just be 1/2 times f of x. So the answer would be 1/2 x plus 4. That's it, right? That's what that'll be, okay? So let's look at number 5. Number 5, it says f of x equals the absolute value x minus 3 minus 1. X minus 3 minus 1. And it stretched by a factor of a equals 5, right? A equals 5. That means it's going to be 5 times the absolute value of x minus 3 minus 1. Just like with our reflections. So you distribute 5 through. So it'll be 5 times the absolute value term, and then 5 times the number. Okay? Real quick, what's the answer? Not quite 5x, because it's absolute value. You can't distribute the number. So it'll be 5 times the absolute value of x minus 3. Minus 5. Good. So g of x equals that.
I have to step out for a minute. Are they good?
Yeah, they're good.
Okay, cool.
Appreciate it. All right. Number 6. This one shrunk by a factor of 1/2. Right? Shrunk by a factor of 1/2. So write down what the answer is. I'm going to write the problem down, and then we'll catch up with each other. So for number 6, we got f of x equals the absolute value of x plus 10 minus 8. All right? X plus 10 minus 8. A equals 1/2 here. A equals 1/2. All right? What's the answer, Lucas?
1/2, and then x absolute value.
1/2 absolute
X
value.
plus 10, and then minus 4.
Very good. Minus 4. How much has got that? Good. So we did our translation, our reflection, and we did our dilation. All right. The last part is basically trying to figure out the graph, and we'll just talk about number 7, and I'll leave you alone. All right. So with this graph here, you have a kind of upside down absolute value. So 1, 2, 3, 5. So that's where that's at. And this is at 1, 2. Yeah. Right? Let me stop. Alright. So the vertex is at 3, -2. Vertex is at 3, -2. And the next point is basically down 1 and over 1. Okay? And we're coming up with this equation based on the parent function, the absolute value of x. Okay? So what you want to do is you want to identify all of the transformations. What are all the transformations you see here?
Horizontal, and vertical, and reflection.
You got a reflection. I don't know why I want to start reflection with an F. Right? Reflection about the x. So that means it's going to be negative, right? What else you got?
Horizontal.
You got a horizontal move. So that means that it's going to be something on the inside. And then you got a vertical move, right? So that means it's going to be something on the outside. So you have, and we'll keep it consistent. So we got something here, we got something here, and then we got the minus sign on the outside, on the left outside. All right. So we know it's absolute value. So it's minus x horizontal move. Did it move to the left or the right?
Right.
So since it moved to the right, it's going to be minus how many other units it is. So it'll be minus, how many units did it move? 3. It moved 3 units this way. 1, 2, 3. Right? And then you had a vertical move, right? Where's my vertical? You got a vertical move. So this is an up move, this is a down move, right? And this went down, so it's going to be minus what? 2. That's your equation, right? That's your equation. F of x equals negative absolute value of x minus 3 minus 2. Okay? So that's pretty much the lesson. Your homework today is going to be in the book. I already posted a picture of the page 16 and 17, and the numbers are also in the Google Classroom. Okay? So if you have any more questions, comment below. If you haven't already, don't forget to like, subscribe. Until next time, this is Do the Math. Out.